The magnetic flux produced in the unshaded portion of the electromagnet is minuscule too. The shaded portion of the flux pi1 is 40 to 50 degree lagging with the unshaded portion of the flux pi2. The two alternating fluxes pi1 and pi2 induce two voltages V1 and V2 on the disc. These two induced voltages V1 and V2 create eddy currents I1 and I2 on the disc. These two eddy currents produce a deflecting torque on the disc. This deflecting torque is directly proportional to the square of the current to be measured, that is Td alpha I square. The disc rotates depending on the residual torque between deflecting torque and the spring action and attains a balanced position. This position is graduated against the actual pointer reading of the parameter. When the disc rotates, it cuts the magnetic field generated by the permanent damping magnet. Hence, eddy current is induced in the disc, which interacts with field of the damping magnet and produces a torque in the opposite direction to deflecting torque. Now you are going to see the phasor diagram of shaded pole type induction instrument. The vectoral sum of two magnetic fluxes pi1 and pi2 gives the resultant magnetic flux pi. These two fluxes pi1 and pi2 induce the voltages V1 and V2, which are in 90 degree phase shift with the fluxes pi1 and pi2 respectively. The two voltages V1 and V2 induce the eddy currents I1 and I2. Each eddy current is lagging by an angle alpha with the induced voltages. Thus, you have learnt about the construction, working and phasor diagram of a shaded pole type induction instrument.